Alright, this is another MCA lesson, and both 7th and 8th grade have seen these properties before. There are properties of arithmetic, but after taking the first round of MCAs, we noticed that there were a lot of, well, not a lot, but there were a few questions about properties on there, and if we brush up on those, we learned them a while back. If we brush up on them, hopefully we can buy each student a couple points on the next time they take the test and boost up the score. So this is just for review, but also we've added a couple things since we learned this way back in the beginning of the year. And we've tried to show it since then in different assignments. Basically though, just to review on what arithmetic is, it's adding, subtracting, multiplying, and dividing. And notice that adding and subtracting are inverses, multiplying and dividing are inverses. We've added two new things to arithmetic since the beginning of the year, and that would be exponents and then taking roots of numbers. And those two are also inverses. So, for instance, taking and squaring 3, we get 3 to the second power, which is 9, and then the square root of 9 is 3. So those two are inverses as well. Those are part of arithmetic too. Now we're going to skip this and this, and I'm going to move a little quick because the students have already seen this lesson. But it's up there for review or to help on the assignment, and for obviously review purposes for the MCA. Different symbols for multiplying and dividing. We brought up today that you won't see me use 3 times 5 like this, because this, a commonly used variable is x. So I don't want to be using this symbol for multiplying if there's going to be variables that I'm working with. It gets confusing. So you'll see me use the dot or the parentheses. Parentheses would mean to multiply. And for dividing, I typically stick to this one, 6 divided by 2. Remember, the bar means to divide. And it reminds students of fractions, but remember, if we reduce this, we get 3 over 1, which is a fraction, or just 3. And 6 divided by 2 is 3. So that's the one I like to use, and I'll point that out again later on here. So these were a bunch of the properties that we're going to talk about. I think this is from the 8th grade book, so page 14 would be in the 8th grade book. But we've added on a property since then that I've added to this. Alright, so our property here, the first one, well, yeah, our first one technically. I don't know why I wrote next. I kind of combined a couple lessons together with this. So anyway, the first one we're going to talk about is the commutative property. And we would say that addition and multiplication are what we call commutative. And basically what this means, if we add two numbers, the order in which we add will not matter. For instance, and it could be more than two numbers, it could be a bunch of numbers. It doesn't matter which order we add them in, we should get the same answer. So for instance, 3 plus 5 is 8, but if we switch around the add-ins, we get 5 plus 3 and we still get 8. So this is also true for multiplication. If we multiply two numbers, the order in which we multiply will not matter. So let's use 3 and 5. 3 times 5 is 15, but 5 times 3 is also 15. Okay? So the commutative property is all about the order of your numbers. If the order of your numbers switches, it's probably going to be the commutative property. Subtraction and division are not commutative. I'll show you that quick. So 5 minus 3 equals 2. Does changing the order matter? Yes, it does. Because 3 minus 5 does not equal 2. We know that 3 minus 5 is negative 2. And so subtraction is not commutative. How about division? No, because 6 divided by 2 is 3. But changing the order matters, because 2 divided by 6 is not equal to 3. Division is not commutative. So that's where I like to use my notation rather than the division symbol. 6 divided by 2 is 3. 2 divided by 6 is actually 1/3 if we reduce this fraction. And you can see that if we change the order of division, we actually just get the reciprocal, 3 and 1/3. Okay? So they are not the same, obviously. So division is not commutative, neither is subtraction, but adding and multiplying are, as we saw earlier. Okay, the next property, those are our identities. And basically we're looking for what makes the statement true. 3 plus what equals 3. Well, we should be able to fill that blank in with a 0. 3 plus 0 equals 3. So we call 0 the additive identity. Since when you add it to a number, you get that same number. So it doesn't matter what number we're adding to 0. If you add anything to 0, you're just going to get that same number. So we call this the additive identity, and that is 0. So that means when we're multiplying, we have this situation. What makes this true? 3 times what equals 3? Well, that should be 1. So 3 times 1 equals 3, because anything times 1 gets us back to the same number. So we call 1 the multiplicative identity, since when a number is multiplied by it, you get the same number. Okay? So those are our two identities. We have an additive and a multiplicative one. Oops. And our next property is the associative property. And this one has to do with parentheses. And it works for addition and multiplication, as we're about to see. But it's all about shifting your parentheses. So first let's just check and see. 2 plus 3 is 5. We do that first because it's in parentheses. Plus 4 equals 9. But if we take our parentheses and just slide them over to the 3 and the 4, now we do 3 plus 4 first, and we get 7, plus 2, and we still get 9. So notice here how the numbers, the order doesn't change, just the parentheses does. So 2 and 2, 3 and 3, 4 and 4. Order of the numbers did not change, just where the parentheses are. That's what changed. That's the associative property. This also works for multiplication. 2 times 3 is 6, times 4 is 24. If we slide those parentheses over, 3 times 4 is 12, 12 times 2 is 24. So we still get the same answer, and the order of our numbers once again did not change. 2, 2, 3, 3, 4, 4. So really what we want to look for with these properties is, did the order of my numbers change? If the order of the numbers changed, it's probably commutative. Okay? If the order is the same, but your parentheses got switched, in some fashion, that's associative. So notice how the order of the numbers did not change for these. We already talked about that. Alright, another very simple property, 0 property of multiplication. This property states that any number multiplied by 0 will equal 0. For instance, an easy example, 3 times 0 is 0. Now I brought up today to the students, do they know why anything times 0 is 0? And they really didn't know. They've always been told that anything times 0 will be 0, but they've always believed it. They weren't shown why. So I asked them if they wanted to see why, and they said yes, they were interested. So first thing I did is I took 3 times 1. And we know that that equals 3. But what does 3 times 1 actually mean? Well, it actually means 3 ones added together. Okay, because multiplication is just a faster way to add. So let's take a look at what 3 times 0 would be then. That means we're going to add 3 zeros together. Okay, so that's why anything times 0 will be 0, because you're just adding 0 however many times it asks you to. But that always comes out 0. So there you go, a little knowledge for you. The final property is the distributive property. This is the one that we introduced later. We didn't learn this very early in the year. This is fairly new. Okay, this is what it looks like algebraically. And the reason it's called the distributive property is because whenever we have a number next to a parenthesis, we know we're multiplying. And this A will be multiplied by the B and the C. It's being distributed to the B and to the C. So to show that, we usually use this. And then if you look over here, this is A times B plus A times C. So that's what it looks like. And if we know what A, B, and C are, this is much easier. Let's try it both ways. First, let's do it this way. If A is 2 and B is 4, C is 5. We get 4 plus 5, we get 2 times 8, oops, giving away the answer. 2 times 9, and 2 times 9 is 18. Okay. Let's see if it works the other way. 2 times 4 plus 2 times 5. So 2 times 4 is 8 plus 2 times 5 is 10. 8 plus 10 is 18. And we get the same answer both ways. Okay? So the distributive property works. But in given situations, you're either going to do it this way or you're going to do it this way. And where you're going to always use the distributive property is in a situation like this, where they ask us to expand. Now we can't solve these problems because they're not set equal to anything. These statements aren't set equal to anything, so we can't solve them. But what we can do is simplify, and they want us to expand. Or in another term, they want us to distribute the 5 to both terms. Or they want us to distribute the 4 to both terms. So, if you want to look at it like this, you can. 5 times x plus 5 times 2. I showed the students a new way to do it today, where we had a little box set up. And in here, this one you put the outside number, just 5, and then your 2 terms on the inside go in here. And then you have this little multiplication table set up. 5 times x is 5x. 5 times 2 is a positive 10. And your answer, simplified answer, 5x plus 10. Right there. So it sets it up very nicely for us. Some students wanted to say that this was equal to 15x. Now, you can't do that because 10 doesn't have an x with it. So this is all the further you can simplify. If 10 had an x, then we could say 15x. But it does not have an x, so we have to leave it like this. Okay? Now our other one over here, we do our little box system again. Get a multiplication table going. Four is on the outside, y, and negative 10. So we do the multiplying. 4 times y is 4y. 4 times negative 10 is negative 40. And your final answer would be 4y minus 40. I think I like that table thing. It sets it up very nice for us. So that's your distributive property right there. Just a couple minutes left. Alright, so we're going to go through these pretty quick here. Name each property illustrated. 5 times 3 equals 3 times 5. Well, notice how the order of the multiplying switched. The order of the numbers changed. So A is commutative. B, let's check first to see if the order of the numbers switched. 3, 4, 5, 3, 4, 5. Order did not change, but the location of our parentheses changed. So B we would call associative. Letter C, 6 plus 0 equals 6. Well, we added 0 to 6 and got 6 again. That has to be an identity, and we are adding. So we are going to say the additive identity there. And letter D, we multiply by 0 and get 0. That's always going to be the case whenever we multiply by 0. So D would be the zero property of multiplication. And we won't cover those. Well, let's at least take a look at 1 times 9 would have to get us to 9, right? So this would be our multiplicative identity. 8 plus 0 would be 8, so this has to be our additive identity. 10 times 0 equals 0. So that, once again, is our zero property of multiplication. We've got 2 more examples here. And we're just going to focus on this step, and this step. Because steps 3 and 4 aren't too important. We want to identify the main ones first. So from the given statement to step 1, what changed? Well, the order of the numbers switched. 4, 15, 25, 4, 25, 15. So these swapped places, okay? So that, remember, we call the commutative property when they switch. The order, that's commutative. And then we look from step 1 to 2, what happened? Well, order of the number is the same. 4s, 25s, 15s. Order is still the same, but the parentheses shifted over. So this we would call associative. Yeah. There you go. And the last two steps, this is why the last two steps aren't too important. Because all that changed from here to here is that they multiplied 4 and 25 to get 100. So you'd write multiply, and then your last step, they solved it. They got a solution, 100 times 15. Now, I asked the students today, why would they even do the problem like this? It looks like a lot of work. But if I just gave you 4 times 15 times 25, you would multiply these first, and then multiply by 4. And that's a little confusing. I mean, we could do it, sure, but it would take a little bit longer. If we rearrange some things and understand our properties, look what they got it down to. 4 times 25 is 100, and 100 times 15 is just 1,500 or 1,500. So they made the problem a lot easier, and that's the whole reason that these properties are used. The last one. Let's see if I have time here. Doing okay. This one I just want to make sure that we know. We're going to look at A, B, and C here. From the given expression to letter B, we would want to say associative because it looks like our parentheses shift, but they really don't. What really happens is the order of our numbers changed. 4, 8, 8, 25, 25, 4. These don't match up. The order of our numbers changed, and whenever that's the case, we have commutative. Okay? Now if we look, and if you notice, the same thing in parentheses here, same thing in parentheses here. The order switched around. Okay, and then from here, the order is the same, 8s, 25s, 4s, but the parentheses shifted over. This is associative. Alright, so that is review and some new stuff with our properties. Let's try to keep that fresh in our minds, and in our power-ups, I'll try to incorporate some of these types of questions so we don't let it go. Thanks.